Welcome students to the last section of this 10th chapter of CBSE uh, science portions and of the 10th grade, and we are looking at one of the beautiful effects we see when we stand outside, that the sky looks blue. What's the reason for it? And the pointed reason, the basic reason is a scattering of light. Let's see how it happens. Now, as we discussed about the quite similar to of our discussion dealing with the Tyndall effect, it's the scattering of light by colloidal particles. Something similar is happening here. So you have the air molecules. The atmosphere is there, which means that atmosphere means air molecules. In the air molecules, there will be very fine particles, and fine particles means size smaller than the wavelength of visible light. Just as we as I mentioned in the previous video, if the particles are very fine, then the light which gets split, I mean the scattered light, will be more towards the blue section of the spectrum, which means that we will be dealing with short wave. So that's the part which we are concentrating in this section, where we are looking at why the sky appears to be blue. So for fine particles, which means when we are dealing with particles of size smaller than the wavelength of visible light, the scattering will be more towards the light of shorter wavelength, that is blue. So what this means is that lights of longer wavelength, that is red, won't be there. So that's a point. So which simply means that the sky will be appearing blue. And not the point that when we compare the wavelengths of red light with that of blue light, red light is quite on 0.8 times the wavelength of, the red light wavelength is on 0.8 times the wavelength of blue light, which basically means that around 2 times the wavelength of blue light. So to put the whole thing in a concise manner, the sunlight passing through the atmosphere, because of the fine particles in air, scatter the blue colors of naturally the shorter wavelength than the red color of the red color of more wavelength, that is that color which is having a more wavelength. This is the reason why the sky appears blue. So a natural question arises: what if there is no atmosphere? What if there is no air? What if there is no particles there to scatter the sunlight which is falling? Naturally, that scattering property won't be there, which means that the sky actually will look dark or something like it will be something like a black color, and that's obviously such a thing won't be that much effectively seen on Earth. I can take the example of moon, where the sky is dark, but if for passengers who are on something like a flight which is flying through high altitude, which means that air is very less dense, there's less air, which means that the effect of scattering is less. So that kind of heights, at that kind of altitudes, there's very less scattering, and there you can see the sky will not be looking bluish, it will be quite dark. So sky appears dark to passengers flying at very high altitudes, that the scattering is not prominent, means it's less scattering when compared to the lower altitude places. And to end this discussion of this section, so all this discussion, all this physics about scattering of light gives the answer why we use the red color as a danger signal. Now, danger signal means that there's something negative, there's something which may affect you not in a positive manner, which means that the signal should be seen at a longer distance. So not the point the signal or the people who are located at a longer distance should understand that there's something negative. So, and for that, the best color is red color. Why? Because we already saw that red is the least scattered. Of the colors of the spectrum, of the colors of the white light, red is the least scattered by fog or smoke. And obviously that means the color can be seen at a longer distance, which means that if we are using red color as a danger signal, more people will be able to know that when instead of us using some other colors like orange or green or something like that as a danger signal. So that's the end of this chapter. Thank you.